Hello and welcome. In this video, we will learn how to convert any given context-free grammar into Chomsky normal form. So Chomsky was a linguist and he has simplified the concept of formal languages. He has formally defined the grammar. He has constructed the rules to define the grammar, and his contribution in terms of finite automata is tremendous. And he has suggested to simplify the grammar using his own method, that is Chomsky normal form. Grammar is said to be in Chomsky normal form if every production in the grammar is having the form either A gives capital B capital C or A gives small a. That means any production should have two non-terminal onto the right hand side, or there must be exactly one terminal onto the right hand side. If all productions are of this form, one of the two form, then we can say that entire grammar, context-free grammar, is CNF. There is another mathematician, that is a Greibach, and he has proposed another way of normalizing the grammar, and that is known as a Greibach normal form. In short, it is GNF. We can say any context-free grammar is in GNF form if every production in the grammar is of the following form: A gives small a alpha. So small a is a terminal symbol. That means the right hand side of all the productions must start with terminal. And alpha is combination of any string. It could be 0 or more variable, terminal, non-terminal, anything it could be. But the first letter must be a small letter. To convert CFG into CNF, we should follow following steps. First one is we have to simplify the grammar. That means we have to remove epsilon productions, we have to remove unit productions, and we have to remove the useless symbols. If you are not familiar with this, please watch last 3 videos into the playlist, where I have explained each steps in detail with the examples. Once your grammar is simplified, then for every production of the form A gives alpha. So alpha is right hand side of any production. If the length of alpha is greater than or equal to 2, then alpha should consist of only variables, because we know that in CNF format, the production could be in the form of A gives small a, that is only one terminal symbol, or the right hand side of any production must be non-terminal, that is A gives capital B capital C kind of form. So if the right hand side of production, which is alpha, if it is greater than or equal to 2, then alpha must consist of only variables, that is non-terminals. For example, if S is in the form of x1, x2, small a, capital X3, B. So here x1, x2 and x3 are non-terminal because they are shown in capital letter, but small a and small b are the terminals. And as per the definition, if the length of alpha is greater than or equal to 2, then all symbols in alpha must be variable or the non-terminal. So the small a and small b, we have to convert it into variables. So that small a and small b we can replace by some variable. Let's call it as a CA and CB. And we will add production CA derives A, CB derives B. So now onto the right hand side of capital S, all symbols are non-terminal, or they all are variable, or they are capital letters, right? And that will satisfy one of the conditions for the CNF. So remember, whenever alpha is greater than or equal to 2, simply replace all terminals by some non-terminal and introduce new productions for all those converted terminals. And in step 3, we have to convert it into CNF. So rules for CNF we already know. So if any production with alpha, length of alpha is greater than 2, then we have to break it down into multiple parts, such that on right hand side we can have length maximum 2. We know that from previous slide that grammar is in CNF form only if production is of the form A gives capital B capital C. That means there should be 2 non-terminal onto the right hand side, or A gives small a, or there should be exactly one terminal onto the right hand side. If you look at the capital S here, then S contains 5 non-terminal, but as per the definition of CNF there could be only 2. So what we'll do is we will break it down this production because it is having length greater than 2. So whenever it is greater than 2, we have to break it down so that if our production is of the form, for example, A gives x1, x2, x3 up to xn, then we can rewrite it as A gives x1 v1. So now A contains only 2 variables. So this is satisfying the condition for CNF, but v1 is not defined. So V1 is ultimately x2, x3 up to xn. But again, V1 is having multiple symbols, more than 2 symbols. So we might need to break down V1 into x2, V2. So that when we replace V1 into the production of A, it will become x1, x2, V2. So again we need to define V2. So V2 represents x3, x4, x5 up to xn. So V2 would be x3, V3. Again we are replacing the later entire string by some non-terminal Vi. And if we goes on, then at the last step, we will have production of the form Vn minus 1 gives xn minus 1 and xn. So you see that all these productions have exactly two non-terminal on right hand side. This we have to do only when length of alpha is greater than 2. If it is less than or equal to 2, we don't have to worry it. So using these rules, in next video, we will discuss the examples that how we can convert context-free grammar into Chomsky normal form. Thank you. That's it for today, folks. See you in next video. If you think this video was useful to you, then please like, comment and share. Don't forget to subscribe the channel Code Crafts. Press the bell icon for the notification of latest videos. Stay connected, stay tuned. Thanks for watching. Bye-bye.